Hey guys, let's start a bit early again, like we've started doing normally. I was busy preparing still, but I think I made it. And welcome to another impromptu stream because I've been too busy doing other stuff to really prepare a video. Oh, Johnny's already here. I thought you didn't have time this early, Johnny. Let me move the camera slightly. Oh no. It moved the wrong way. There we go. There is a question for you in QuinLED Digital since we are still before the official stream start. Okay, let me open Discord real quick. Hold on. Does anybody know when the Dig-Quad will be in stock in the US? Well, they are currently on an airplane. So I would think very soon. Somewhere next week, for sure. Live? Yes, this is live. Hello. Oh, you don't have time after 10 o'clock. Well, then we will have to finish quickly. It's good we started early. What's the Coke of the day? Well, I wasn't feeling very adventurous today, and I was kind of like, I just want regular Coke. Well, zero, but still. So yeah, it's regular Coke day. That happened. So I'm still looking at all the statistics here because I've started streaming and recording in different bit rates in OBS, and for some reason that taxes my GPU at 100% some of the time. But I've been looking and we have 0.0% skipped frames or rendering lag. But there are some, but I guess it's okay. I don't know. 0.0% is pretty good. Tom Porter's here. Hello, hello, Quindor. What's the Coke of the day? We just did that. We're just here for the Coke flavors. Yeah, I get that. I mean, sure. Regular zero, right? Yep, that's regular zero. Yep. Brabants kwartiertje. Yeah. Yeah. Often I'm a Brabants kwartiertje late, but for streaming, for some reason, I'm also often a Brabants kwartiertje early. I don't know why that is, but, you know, it's okay. You have an Nvidia card. Yes, I do. This is a GTX 1080. And I think it has to do with the copy buffer, because that, if I look at the Windows Task Manager, that's what I see spiking. So it's probably copying the stream to two encoders, and that's what I'm seeing causing a 100% spike. But as long as I'm not having any lag, I guess it's fine. Let's go epic today and put everything on mains voltage. Let's not, because I'll die. Alright, I just noticed the LEDs in the background aren't doing what I want them to do. No. Let's fix that. Okay, now they're all blue, and now they're all random. Oh, random is the same on all the channels? Oh, okay. Well, it's okay. It's nice. Oh yeah, of course I'm using NVEnc. I'm encoding one stream at 4K 60, or well, both are 4K 60, but one is at 16 megabits, which goes to YouTube, and then another one is at 100 megabits, which is stored locally. And the YouTube stream is resized to 2560 by 1440, but the local one is native 4K 60. But it's just the copy buffer, which is showing some odd behavior. I guess I could show you. I guess. Let me see. If we go here, And then I take this one, and I want this one. There we go. Okay. Let's reset that. Okay. Now it's a bit small. Okay. How does this work? Oh, now we can see everything. Okay, so I have to be in another screen. That's odd. So this is my task manager. We can talk about this streaming machine, I guess. I recently updated it. So it's a 5900X with 12 cores. Plenty of processing power, as you can see. And then it has 32 gigabytes of 3200. It's supposed to run at 3600, but then I ran into issues. So I downgraded it to 3200 megahertz memory. But 2 sticks, so in dual channel, but 8. Plenty of memory. And then I have an insane amount of SSDs, because this is a 2 terabyte SSD and this is a 2 terabyte SSD. I bought those a while back and made an article about it and everything like that. Then I have 2 of the older Chia farming SSDs in there, which is my boot drive and my scratch drive or whatever. Simple network connection, which is doing the sending like I talked about, so about 16 megabits on average. And then a GTX 1080, because that was the card before I bought the 3090. So this is my old desktop card, which is in here. And everything's fine, except that if I run the dual stream, you see the copy behavior here. It often hits 100%, but it doesn't seem to be causing any issues. So, I guess that's fine. I mean, memory-wise, we're fine. Yeah. We have 8 gigs of video memory and we're using 4. So yeah, that's just the odd thing. It's spiking to 100%, but it's probably doing a main buffer and then the secondary one is copied off of the main buffer, and copying from the primary to the secondary buffer is probably causing that 100% spike because it does it as fast as it can. So it's likely not an issue as long as you're not at 100% all the time. I just want to make sure I'm not lagging. So, yeah. Yes, I'm using OBS to stream. Yeah. And currently, since the stream started, we have had 13 missed frames due to rendering lag and 8 due to encoding lag. But in total, that's 0.00 something %. So, and it hasn't increased in a few minutes already. I guess it's fine. I don't know. I was just paying attention to it, making sure everything's nice and smooth, because I want to be, yes, nice and smooth. Oh, Unexpected Maker is here. Well, 4K 60 is taxing. Yeah, sure, of course. I get that. I'm just wondering about the behavior. Oh, no, that's the wrong window. This one? Yeah. I'm just wondering about the 100% copy behavior. That's it. Everything, it's working fine. And I mean, this PC is built to have 4 times 4K 60 ingest. So there's a D-Link-Quad HDMI recorder in there, which has 4 times 4K 60 HDMI in. And we recently did that, and that worked fine because we had a computer input piping in, and then we had 3 4K cameras, and that all worked fine. So it's been working fine, and as you can see, especially CPU-wise, there's plenty of resources. Half the CPU cores aren't even loaded. So yeah, but it's I guess at some point I might want to upgrade to a 30 or maybe a 40 series card, because those do have an upgraded video encoder versus the 10 series. So who knows? Maybe at some point. But I had a 1080. I mean, a 1080 is nothing to snuff at. So yeah. Quindor's next Coke is on me. Oh man, that's cool. Thank you very much, Tom Porter. So yeah, regular Coke. I didn't crack it open yet, but we're still 3 minutes before the stream starts. So let's do that. I'm not in the right side of the screen. There we go. It's just nice to make hardware that works. That's absolutely right. And the previous streaming PC had its issues while booting, and it was a quad-core Intel, which was barely getting along, especially when I went into multiple 4K cameras. And this Ryzen machine, just like, yeah, you want 4K streams and all kinds of overlays and multiple scenes and transitions, and all fine with me. Let's do it. It's just a video card that might need a better encoder, but we'll see. We'll see. I have time moving to the projector then. Okay, nice. What? My strips aren't the right orientation. What? Shouldn't that be blue and yellow? Oh, well, we can make it blue and yellow. So, I guess, let's do some WLED editing. I guess I can share that. Where is it? There we go. Yeah, now I need to reset the transform again. Pew. Right, so let's go to PC mode. There we go. I have 4 segments of 72 behind me on the wall. And I think the easiest way, because it's on Synolon Dual right now, the easiest way would be colors 1 and 2. And then selecting something yellowish. And then 2 bluish. Oh, that's a bit much bluish. Oh, that should work. Let's see. It's not really yellow. Okay, more reddish. There we go. That's a bit blown out. Let me lower the intensity. Oh, right. Okay. Less blue. Okay, now it's not working at all. Why not? Oh wait, I adjusted the wrong one. There we go. That's the problem. Okay, that's yellow and bluish enough, I'd say. I mean, less blue. There we go. I guess we could do this. Okay. So yeah, I always toy around with the effects in WLED to kind of create what I like. I guess this works. Oh, there's a bit of red in there now too. What are you gonna do? Where's my chat? I still haven't drank from that Coke. Well, the RGB lights behind me, they're on a very slow loop. So although when you look at them directly, you don't really see them changing color, but if you look back, especially if you look back when the live stream is done, you'll see that they've been all kinds of random colors, but they do so very, very slowly. So yeah. Yeah, I had 2 blues, I know. Not working, ship it! Oh man, I've been working on so many PCB stuff this week, and I've also been soldering a lot of boards and prototypes and stuff like that. Nothing I can share right now, just so you know. But I've been doing so much that the smell of the flux is kind of stuck in my nose. It's starting to get out of there a little bit now, but yeah. But I got done what I needed to test and do, and I ordered 2 new prototypes of the things I was testing, or actually 3. And so that's good. The work got done, and we're moving it along. But yeah, start time. Right. So okay. I already asked how you guys were doing, but how are you guys doing? Washing machine effect will work nice. Yeah, true. Great! Trying a new whiskey, the Aaron 10 years, says Joey Portman. Ooh. How's it going, John Kuster? Doing great, says Unexpected Maker. Awesome. Yeah, it was fun to hang around in your stream last night while you were designing stuff. So let me put the Coke in a safer place, and let's go to the top-down cam, because the main topic of the day, because I have to find a topic, is basically these things, and those are okay, I got it. Those are little plugs that need to be refocused. There we go. And they're basically little plugs, and a Discord member, Wings Costa, if I pronounce his name right, he pointed me to them, like, he was like, hey, I use these in my setup and they work pretty well. And, well, if you look here, there are these tiny little modules or plugs you can buy on Amazon or AliExpress and stuff like that. These are all from AliExpress, and I got 3 different types. But they have a base, and the idea is you take a low voltage DC cable, you split it, you put one side into this base part, and it has a little pricker here. I don't know, prong. Yeah, anyway, it'll basically, once you twist this on, it'll insert into the cable, making an electrical connection. And then there is the top piece, where I think you just squish it, you feed through the wire here, and then you squish in the wires on this side, and then you screw that together, and you've basically tapped or made a tap on that cable. And these are officially for garden lighting. So you basically have a sort of bus bar system where you have a thicker wire running through your garden, and you put, I don't know, 5 volt, 12 volts on that, or 24 volts even, and you tap off of that for each of the lights. So here's the instructions. Separate the wire, put the bottom part on there, pierce into the wire, so yeah, okay, and then twist and tighten. So then you've basically made a splice at that point where you want to put a light, and insert the light wire through the top cap, and then put the wire into the joint and screw the cap. It's not even English. Awesome. Twist and tighten, and then pull the wire to ensure connect well. Okay, so to make sure it's connected. Okay, and if the power cable is too thick, you can pinch the wire with pliers. Oh, that's kind of the same like we do with ferrules if they don't fit the terminals. Then insert the pinch port into the base. Cool. When you want to replace the old connector, cut off the previous connection and peel off enough insulation from the wiring. Okay. I don't know what they mean with that, but that's fine. So let's, they have, yes, they have different colors. Perfect match for 12 and 16 gauge wire of low voltage landscape lighting. Okay, cool. That's fine, because, of course, I prepared a little bit. My tower of testers is falling. So here I have some 12 gauge, I think. Yeah, if you look over here, that says, okay, I need to make it. That says 12, so that's 12 gauge, good. And this is 14. Well, I have a whole bundle of 16 gauge. So yeah, that's going to be enough 16 gauge. And this is all silicone cable. Now, I don't know if you actually use that in your garden. But no orange, bad product. Okay. But yeah, well, we'll see. This is the cable I have. I could go looking for other cable, but I think I'd like to try it with the silicone cable. So, as I mentioned, I got plugs from different suppliers. I don't know if I mentioned that, but I got plugs from different suppliers. So this is one of them. And I have all 3 linked in the description below. They're all from AliExpress, so they're not very expensive. So let's get one of each, or 2 of each. And the thing I was thinking of doing is just getting my 12 gauge, putting 12 volt on there, and then using my my testers we also used last week to put a load on there and see what the voltage drop is over the connection, basically, and see if this would be suitable for 5 volt or 12 volt LED strips if you wanted to use a 12 gauge bus bar system, basically. If you could do it with these, because then these supposedly are weather tight or okay in weather. I don't think they're weather tight. I think what will happen is basically you're separating plus and minus, so as long as they're not in a puddle together, they're not making contact. So in theory, I guess that'll be fine. So you can't submerge them, because then they'll short. But as long as they're not submerged and just get wet, I guess that's okay. But, yeah. What do you guys think? Do you think it'll work? Do you think the connection will be strong enough to, like, draw 5 amps out of that? Or you think it's gonna fail horribly? Hey chat, I'm a bit late. No, oh, Andy's here. Nice. Whoop whoop. No pink. Bad product. Come on, it's not all about colors. We want magic smoke, so fail. Well, who knows? Maybe we'll melt one of these. I guess that'll count as magic smoke. Melting is okay. Melting is in the magic smoke category, I'd say. Right? I mean, yeah. So, I guess we should set up a test. Let me zoom out. Nope. Oh, a bit too much. Okay. So let's take this 12 gauge and let's keep it this length as it is right now. Do they give a max amps for the company itself? No, I couldn't find any statistics really. Just that it supports 12 gauge and 16 gauge. So, sure, those are nice values. I mean, those are good to use on cables. Also for 5-volt stuff. Let's move that out of the way. So, let's prepare one of the cables first. So, this is the 10 gauge, and we'll be using that as a sort of bus bar system, basically. Before we do that, let's actually see if we can get the cable into there using the first part. And I don't know, I'm just going to take this one. And so this, okay. So can I even get this in here? Oh, yeah, I can. Okay. Right. So let's first see if it actually makes a connection. So I just push this in there. Okay, I should just show you. Okay, that went pretty easily. And then I can screw this down. Let's screw it down tight, you know. But this is plastic, so it's okay. That's pretty hand tight. But as you can see, it's squishing the cable. Okay, that's good. Let's take the top out. Okay. Yeah, that's a decent bar there, I guess. This isn't. Yeah, this isn't going anywhere. That's good. Let's get the multimeter. Yeah, being able to insert 12 gauge would suggest it can handle a bit of amps, but it also has the 12 gauge to be able to be a long distance, because a voltage drop, you want to be able to use thicker cables. So I get partly it could mean that it can handle a lot of amps, but I think they support 12 gauge because of the longer distance. So let's insert this probe into here, and let's see if we at least get continuity. So this one goes here, and then it'll touch here. We don't? What do you mean? Oh, there we go. Okay, so going through the whole cable. Okay, I'm trying to do this in hand and on camera, and you know, stuff like that. Okay, we basically, according to my meter, get 0 resistance. Well, okay, that's fine. That's good. But at least it's making contact, so we know that works. So okay. Sure, let's test that, Philip. That's a good question. If I can still dislodge this. Okay, there we go. Let's take it off again. The pin seems fine. Okay. Wow. It's supposed to have... Okay, yeah, there's a slight spot there where it punctured the cable. But other than that, the shielding seems perfectly fine. This is 12 gauge. Oh, it actually says it right here. 12 gauge. Yes. Okay, let's snip that off and use this end to connect to the power supply. But I do want to have non-pinched wire for that, I guess. So, okay, let's remove that. So, that was a little testing piece. And let's put some spade terminals on there. But I need to get the right ones. I think it's the thickest ones I need this time. Yes, let's get these. Because we need to make a power supply connection. And I want to have the other side connected to one of my testers. So actually we need 2 of these. Okay. And should have them in black too. Oh no, we're all mixing all kinds of plugs here. Okay, 2 of those. Right. This box is barely big enough, but the more I use, the better fit it becomes. There, closes just fine. Okay, so we're gonna make connections which I can use on one of my my testers. So I need one that'll go in here and a part that'll go in my power supply. I have a 5 volt and a 12 volt power supply on my bench right now, but we'll use the 5 volt to basically simulate a worst case scenario, I guess, to look at voltage drop. Let me reassemble this one before we lose parts of it. Well, yeah, the cable could handle maybe 20 amps a meter, but it doesn't mean that the total connection will. And of course, we saw the little prong here. I don't know how much current we'll be able to transfer over that, and that's exactly what we're going to try. If it's suited for 1 amp, that's fine for a little light maybe, but not an LED strip if you want to use it as a bus bar. So that's what we're trying. Okay, so we're going to prepare these cables, and I need a bit of stripped cable, not too much. There we go, something like that. A bit more. Can we still get it? Nope. Okay, let's get a little bit more then. There we go. Okay, and this side too. There is always a debate if you should twist them or not. I do. I twist them. But yeah. Okay, I need to get my crimper. So we used one of these, and although normally these are color coded, I got these from AliExpress, and you can get them any color you want to. So I'm just going to use the last slot and make sure it lines up with the back part of it, basically, because you want to squish the back part. Okay, give it one tick and insert the wire, and it. Oh no, I squished it over. Is that going to be okay? I think so, because you want to have it come out a little bit, and then you want to crimp it like so. And I would have preferred it coming out a little bit more, but I maybe stripped it a little bit short. But still, this is going to be fine. Oh, this is not going to be fine. Well, I always do the tug test, and it failed. I need more wire. So let's get a little bit more wire. There we go. Okay, now I need another red one. Luckily, these come in packs of 100. You know. Okay, let's do that again. This time I'll do it this way, just to verify. See, now we have it sticking out nicely. And let's see if we can get it in here. There we go. And just to be sure, I'll do a double crimp on it. There we go. That shouldn't be going anywhere. Okay. let's do the black part. Or the negative side, I guess I should say. Okay, insert it into your crimper. Make sure it's sticking out a little bit. Crimp it down like that. I'll do a double one again just to make sure. There we go. These should be perfectly fine to transfer lots of current. So we're going to do the same to the other side of the cable. One side we're going to attach to the power supply, and the other side we're going to attach to a load. And well, we can see how much voltage drop and stuff we get on that, and then we can start adding loads in between on the wire somewhere, basically using it as a bus bar. A little bit more. Okay. Oh. A little bit more. I'm too conservative on my my wire cutting here. There we go. That should be fine. Or maybe it's too much now. I don't know. I don't know. Yeah, and this is silicone wire too. So I'm just reading the discussion in the chat. You can push a lot of it through there before it'll heat up too much. But we're more concerned with you'll hit usable voltage drop or unusable voltage drop way before you hit the burning temperature of the wire, basically. So, okay, oh, that's a nice crimp. Look at that. Okay. So it depends. If you're using higher voltages, you don't get to that voltage drop limit that quickly. So if you're using 12 or 24 volt, if you're using 5 volt, you're going to get there pretty soon, because you don't want to really lose more than 5% on that cable, or 10%. So that's 0.5 volt with 5 volt, but it's already 1.2 volt with 12 volt cable, or 12 volt power on there. So it really depends on what you're running, and yeah. And who knows, maybe you're using the 24 volt buck converter setup we've talked about before, and then you could use much thinner cable, make it really long, wrap all around your garden, and just tap off the points you need, and yeah. So let's take our let's start with the 5 volt supply, because as I said, that'll give our worst case scenario, and we just want to see what the voltage drop is, right? So let's remove these wires. Thanks, Chris Starr. That's what I try to provide, something people can understand. And I try to go into the techniques, but, you know, into the techniques. That's great English there. Oh. Best English ever! But yeah, I like to deep dive into the real reasons and the tech behind it, instead of just saying, this is how it works, and you just have to accept that. No. I want you to understand how it works, so you can theorize how to build setups and stuff like that, and calculate yourself. So, yeah. So if you look at this crimp, you see that the wires are kind of touching the terminal. That's fine, you know, as long as it can't move. But with these 4 connectors, if you screw them down, even just pretty tight, they're not going anywhere. So that's good. So power supply is sorted. Let me find the right plug for that one, because there's 2 on my disc. It's always dangerous, of course. I think it's this one. Okay. So then we have all this wire, and we're going to zoom out now. Nope. There we go. And we'll use a tester, one that doesn't have wires attached right now, and we'll attach that to the other side. And with these fork terminals, I can actually use the 4-way binding post with the 1 terminals, because one is going to actually generate the load, the outer ones, and then the inner ones are going to be the sensing pins. So if you're using a single wire, you have to use little bridges like that so that it actually senses stuff. But using these fork terminals, it actually bridges both, so, you know, makes it easier. Let's screw that in. Okay, and this is, you know, again, pretty tight. That's good. So, okay. I need a 12-volt supply cable for my tester, because the tester needs its own power source. There we go. Cool. Okay. Power supply isn't on yet, so we're not seeing anything. That's fine. Let's turn it on and see if anything explodes. It doesn't explode, and we're seeing 5.07-ish volts. Stay down, little screen. Okay, that's good. So this cable, you know, is currently giving 5.07 or 76 volts, and I know these power supplies are 509, so that's fine. And we can say, okay, let's give it a 2 amp load. There we go. Now it's loaded for 2 amps, and we see a slight voltage drop to 5015. That's fine, and we can say, okay, let's say we want 5 amps through this cable, right? That's what we're doing right now. And that means the voltage it's sensing with the load on there is 4.926. That's perfectly fine. You're always going to see a slight drop in voltage once you apply a load. And in this case, we can probably go, you know, okay, 15 amps might be a bit much, but it's still 4.6. That's still okay. As I said, we'll be able to accept, let's say, half a volt drop. So as long as we stay at or above 4.5 volt, I'd call that a pass. And I mean, 15 amps is a pretty decent rating. This Meanwell power supply is 5 volt 80 amps, so we're not going to overload that anytime soon. But yeah, I mean, that's if we go back to something a little bit more realistic, with 10 amps through this cable, 12 gauge, so that's pretty decent. We get 4.7 volts. Okay, sure. So let's go back to 5 amps, which is our testing load, I guess we'll say. So let's turn that off. And let's get our 16 gauge out, because we said it said it was very suited for 12 and 16 gauge. Okay, so here's our 16 gauge. So let's take a part of that. I guess, you know, you have the bus bar wire running, and then you need a little distance from that to reach your goal. Okay, so this is our distance. I don't know what it is, but it's, you know, should I measure it? I guess I should measure it, huh? I don't know. Yeah, I connected one side to a PSU. It's not magically generating power. Come on. Okay, let's turn it off, by the way. Okay, so we have this distance from our bus bar to our light, right? And in this case, our light is another load. Okay, well, we have to prepare that cable. So one side is going to go into these wire clamp plug thingies. Fine. But the other side is going to go into a load. So let's prepare that the same way we did this one. Normally that would be your light or whatever, but yeah. Let's just use a load. So I'm going to do a little hacky trick. Is it a hacky trick? I don't know. So I need the same size spades or the fork terminals on there to be able to fit into this load. But 16 gauge won't fit into those fork terminals. So what I'm going to do is I'm going to do something probably electricians will hate me for forever, but who knows. I'm going to put some wire ferrules on there. Oh, wow. Okay, those are too tight. Okay. So, okay. Really? Still won't fit? It should fit. No, still doesn't fit. Need to go another size bigger. Luckily, we have those two. There we go. With wire ferrules, it's basically the game of getting the smallest one you can on there. And then you have the right size. Okay, so we're going to crimp these ferrules on there. Okay. There we go. We now have a ferrule crimped connection. And then we're going to take... Well, I guess we could insert these wires and then do the little bridgey wire thing. Yeah, let's do that. That's, I don't know, the best way to do it. I don't know if there's a best way to do this. Okay. So let's take whatever wire was in here out of there. And let's insert this wire in here. So again, the reason this needs extra wires is these outer terminals are the ones that generate the load, but the sensing is done on extra terminals. Now the reason for that is something called 4-wire sensing you can do with that, which will give you more accurate results. But it's not really something we need to bother with right now. So to basically bypass that... get in there. So basically bypass that, we're just using a little bridge wire there so that it senses the voltage at the same point as through the same line. But that's a valid way to do it. So okay, that's screwed in. Good. And now we don't need a wire stripper, we don't need a cutting tool, and we don't need a screwdriver. Because in theory, we need this part, and then our bus wire, and we should only need these guys, because this is going to make the connection, right? So, let me... hold up. Okay, let's do it that way. And we're going to test 3 points, I think. I have enough testers for that. So, we're just going to, I don't know, splice it in here. Is that a good idea? Because the power supply is right here. So we won't have a lot of drop on there. That's good. So they said to separate the wire. How do we separate the wire? Is this our first problem? Project failed. Can't separate wire. Oh, okay. That's... I need more coke power. Good evening, Kim. I'm not going to try your last name. Right, how do we separate these wires? Does anybody have a good trick of separating these wires when there isn't an easy point for it? Damn, okay. So we might still need the scissors. Okay, let's try having it lay flat and then just puncture it, I guess. Yeah, so we punctured it, okay. Yeah, but problem is, see here, this silicone is pretty delicate, I guess you could say. And, well, I punctured it, but it might have already cut it the wrong part. Oh, okay. Okay, so we didn't puncture it completely. That's good. Right? So, okay. Okay, that's fine. We now have our split wires. So let's take these. These are both from the same vendor, because we have 3 vendors. And the idea is to unscrew the caps. Do Dutch not have a sharp knife? What? Maybe. Okay, let's see what the up position is. And let's squeeze that in here. And over here. I guess we can interleave it a little bit so that it doesn't become too thick. Okay. Right? Sure. And then we just screw in the caps. That's called 112 in advance. Silicone has great surface tension. Oh, okay. So you're saying with PVC it would probably been easier? Let's make sure this is oriented kind of the same way. I think it is. Do you still have a Quinn box with the addresses exposed? You'd have to go searching for that, I think. And I think I blocked those off, but, well, you know. Okay, so those are fairly tight on there. You know, we want them to last, but that's good. So we take out the top. Okay, and there's these posts in there. Okay, interesting. This is our wire. I just said we didn't need our tools anymore, but that was a lie. Because we need to strip off, you know, parts of the wire. So let's strip off the same amount we put into the fork terminals just now. Where I live, an ambulance should be passing in the next 5 minutes. Where I live, if an ambulance needed to come, it'll take 20 minutes at least. Oh no, I twisted the wires together. Should I have done that? Let's go back to the instructions, because one of them came with instructions, right? Okay, so instruction-wise, what did it say? Tighten, okay, and then insert light wire through the top cap, put wire into joint and screw the cap. Oh, okay. So, they say we need to put the top cap on the wire. Okay. It's too bad they don't mention how long of a wire you should expose. And then they say just put it in there. And I'm just going to squish it in there. Okay, let's make sure we screw that down tightly. Okay, well, that's, you know, let's give it a tuck test. Yeah, that's in there. Okay, let's do the other side. Right, okay. And I'm just gonna squish it in there. So this is 12 gauge as the bus bar wire, and then 16 gauge as the... oh, this is an interesting problem. When you're twisting the wire, you're literally twisting the wire. I guess, is it supposed to work like that? I don't know. Oh, okay. Well, I guess that's okay. I mean, I don't know. Anyway, this is our first connection completed. And I can see this being pretty easy to do while out in your garden. You basically just need a wire stripper for that one part. No other tools are needed. And as I mentioned before, because these are separated, even if they get wet, I guess that's okay. Because this isn't going to stop the rain. This might stop the rain, so not get into the busbar wire, but this certainly won't. But then these are two separated poles, so I don't know. Okay, so we have our wire, and let's fire up the testers. So I need a second 12-volt wire. At the end of the stream, this will become one giant mess. It's okay. So, okay. 0 volts because it's currently off. Let's turn power on, see if that works. Sure. And it's reading a slightly higher voltage than the last one, but that is because this one is at the end of the line, and this one's right at the front of the line. So it's logical that the voltage is a little bit higher. I haven't been paying attention to chat. Should I pay attention to chat? I guess I should. Where's my mouse? Do I have a mouse? If Quinder is testing lights, I can see glow on the horizon, Philip. Nice. I'm not in Eindhoven. I'm near Den Bosch. I'm in a little village near Den Bosch. You could fill the spot with grease of silicone. Yeah, I guess once it's connected, you could even just dab hot glue on there or silicone or whatever, sealing the top part. Ah, that's a good suggestion, actually. Pay attention to us! Yeah, I know, sorry. Cool, okay, sure. So, we have power now. Let's do the 5 amp at the end. Of course, we'll see a voltage drop where the load is, because that's at the end of the cable. But at the front of the cable, the voltage drop isn't that much yet. So let's, I don't know, let's start with 1 amp. Oh, that's pretty good. It'll do 1 amp. Let's do 2 amps. Okay, it's starting to drop a little bit. Let's go to 3 amps, 4 amps, 5 amps. Huh. That's fine. I mean, yeah, sure. There's more drop than going through all of the cable to the back. We get 495, and even though this is much closer to the power supply with a 5 amp load, we get 4.88. So the connection point is definitely having a higher resistance than the rest of the cable, but 4.8 isn't too bad. It's okay. And if you're using 5 volt LED strip, a 5 amp load is kind of expectable at an injection point. That's reasonable. And then with 12 volt, I think it's 2. So get the FLIR out. Oh, okay, that's a good point. Sure. So let's leave this here. Well, let's set it to 10 amp then. Right? Let's test it. Okay, 4.7 volts with 10 amps going just through this connection. And then you also have to keep in mind there is this 16 gauge cable connected here, which will also be dropping some voltage. So it's not there's always going to be drop at some point somewhere on the cables. But let's get this over here as much as I can. There we go. It's a bit dark, isn't it? Right, this is good. So here is our connection point. We're still at 4.7. Let's see if it's dropping. Because if the voltage is dropping, that likely means that something is heating up too much and its resistance is rising. So let's keep a little look at that. We're currently drawing 15 amps through that 12 gauge cable, but it's a 12 gauge cable. So I mean, let's see what happens if we stop the end load. So let's disable that. See if that raises the voltage. I don't think it'll raise it that much. Yeah, 20 millivolts. That's nothing. So let's, I don't know, let's keep that running. Nice and warm. Oh! So, stream done already. Tonight's event was cancelled, so I'm here till the end. Nice! Vaseline, yeah. And I mean, I don't even think you need to insulate the bottom part of it. I think just making sure it can't get into the holes where the wires stick out, that's probably going to be enough. Okay, we're still at 4.7, even with a 10 amp load. That's perfectly acceptable. Okay. So let's build my flare here, and it's an old one, so I need this little adapter here. Because, you know, it's all nice and dandy if it does it, but then if it drops too much voltage while doing... well, it doesn't drop too much. If it gets too warm while doing so, it's not going to be useful either. So let's see if this enables. There we go. Yeah. Now do 50 amps! Hold on. Let's see what it does first. Okay, so as you can see, the connectors aren't... Oh, okay, I need to move the testers out of the way, otherwise it will react to that. Okay, so here's my hand. My thumb, what temperature is my thumb? My thumb is 34.6 according to the meter. Okay, that's fine. But as you can see, the connectors aren't hot at all. It's actually the cable that's hot. So the cable is 33 degrees. That's the 16 gauge. That's slightly warm, sure. But this is 29 point something. But then again, the desk... How warm is the desk? The desk is 28 too, so that's not bad at all. Let's see if maybe on the other side... I have to try and get my fingers out of the way. 30 degrees. Yeah, I don't see any hot spots or anything in those connectors. And I'm actually manhandling this connector now, and you can keep an eye on the voltage. That doesn't really change either, so that means the connection is actually pretty good. Dr. Quindor, my thumb is 34C. That's good. Sure. Yeah, this is actually fine, because I mean... Where do you get the FLIR adapter from? This, I don't know, this is some kind of... Oh, no, bank accounts. This is a U-green little adapter block from micro USB to USB-C. And since USB-C, which is on the phone side, is reversible, it'll always work. So, yeah. Because my FLIR just had micro USB, so, I don't know. Okay, it's 32 degrees now, that's fine. I mean, the cable is... 33 degrees, so that's fine. 33. Yeah, it's working better than expected. That's good. Oh, Mako's here. Yeah, we're still going. So we now have one connection point doing 10 amps already. Let's disable those for now. Let's turn off the power. And, okay, I need to remove these wires. There we go. So we have our first splice point. Let's go further down the cable and make a second splice point and use a different vendor's thingy for that. Thingy, yes. Thingy is always the technical term. I don't know. We're further down our garden and we want to make a splice point over here too. Right? That's what we want to do. So let's see if we can get the cable flat on the table. Push it through. And then pull it apart. Oh, okay, sure. That worked again. Okay. So I had 3 different vendors and then I mixed them up. think these go together. Yeah, and these go together. Yeah. And these are the same type, aren't they? Yeah. And the ones I just used, okay, are this type. So let's use these. Okay. They're slightly different style, but basically the same. So, same idea. We take our cable, we split it, and then we push it into the bottom caps. And I interleave it a little bit so they're not exactly at the same point, because then you get a big bulge. Okay, and then we just screw this on there. Let's screw it on tight. Oh, I think I actually skipped the thread there. That's okay. Okay, that's tight. That's good. Yeah, so it pinches pretty tight on the wire here. That's okay. What kind of wire are we going to use now? I guess we're going to use 16 gauge again, huh? Let's use 14 gauge. Because I have a 14 gauge lying around here. Is this 14 gauge? Yeah, this is 14 gauge. Okay, so on one side, we're just going to insert it into here. So we take off the top again. Fast is fast. Absolutely, Philip. Okay, well, it's the same kind of post style. Let's split this one. And let's strip off a decent amount. There we go. That's a little bit more than 1 centimeter, I'd say. And should we twist it or should we leave it untwisted? Vote in the chat. Twist them or not twist them before we insert them into the cap. Yeah, I like doing them, Draastal. I mean, I don't know the answer. I just like figuring it out together with you guys. So we'll do the actual tests. Not the... what YouTube seems to be filled with, the... oh, look at this product. I really tested it really well. Good. I tested it good. And it's great. But then they don't show the test. They don't show any results. They don't show anything. They just say it's great. And we're supposed to believe them? What? So Andy says twist them. And Philip says you did the first one with twist, so try one without. Oh. Oh. Adam's comments being blocked. Twist is easier to shove in holes. That is true. But we let's try it on... I just asked a favor on Discord. Please check. Ooh. No twist. Not twist. It's going to mesh. You should have to put the cap on first. Okay, don't twist. That's right. We didn't twist. We twisted the other one. So... let's see if we can do this one untwisted. Let's get all the hairs. Oh, I'm having a tough time getting it through. Oh. Remember it said 12 and 16 gauge, and this is 14 gauge? There's a stop in there. So I can't actually push the wire through there. Oh, I'm not twisting. I'm not twisting. Sorry. No, let's try it untwisted. Yeah, I'm having issues getting the wires in there. Okay, I bunched up the wires, so it was a nice test. But I think we're going to have to twist to get the wires through there correctly. Right? Because we need all the wires, not some of the wires. So 14 gauge might actually be a bit too thick, because the insulation won't go fully through there. Is that a difference in design? Let me check. So this is the other one, the other type. Yeah, so the other type will allow the nut to go all the way over the cable. But this type doesn't. Because it's you know, the hole it has is meant for a thinner cable. I guess. Maybe I can force it through. No, can't force it through. Okay, well, this is enough. And maybe that'll work better for being weather tight. So let's try it like this, okay? So I have it inserted as far as it can go. And it's sticking out this much. And let's try and get that in there. So there's the pole. So I'm just going to mush this in there. And then twist it shut. While keeping tension on the cable, I guess. Okay, that's, ow. Yeah, that's tight. Okay, sure. I think that'll work. So let's do it for this one too. So we have this much sticking out. And we just smudge that in there. And then while keeping a bit of pressure on the cable, let's close that nut. So links to these are of course in the description. And they're from AliExpress. They also have them on Amazon. But I forgot to link those. Ow! Okay, yeah, okay. These are, you know, hard plastic. So let's tug them. Okay, this is fine. Yeah, that's fine too. And this is, you know, negative to negative, positive to positive. That's good. We have a bunch of wire here. So I guess we need another tester, huh? Let's get this one. Remove the cable that's in there. Oh, sorry, you can't see anything. So let's take that one out. Oh, we still need to put ferrules on here. Okay. Well, I had an issue getting the cables through there with no twist, so I'm not sure if no twist is the way to go. We can do another part with no twist if we really want to. Okay, let's do blue. I think blue should fit, even though it's 14 gauge instead of 16 gauge. Yeah, blue fits nicely. Okay, that's good. Oh. Yeah, perfect. Perfect, perfect. Okay, so those are crimped on there. And then we'll just insert them into the terminals, which we need to open a bit further. There we go. And I also need this little wire here. Okay. And the little wire. Let's tighten that down. Good. So, it's becoming a bit of a mess. But we now have 3 testers here. This one is our first splice. This one is... let me just try and get this out of here. Let's put all the cable over there. And the splices. We don't need those in the shop right now. Okay, so... First splice, second splice, end of the cable, right? Now, we need 3 12-volt wires. We're just going to make a mess out of it. So this is also why I went for multiple testers instead of one big one. There's multiple reasons for that. Oh, it rebooted? Why did it reboot? Okay, sure. Okay, that's all secure. That's secure. Good. Okay. So let's do... Oh, no, it's not. Let's go to 5 volt again. Or 5 volt. 5 amp. Oh, no. We need to enable the power supply. Almost crimped the OLED. No, that's okay. Okay. Sure. Still the same. I mean, we punctured the cable now at 2 points, but I guess that wouldn't influence it too much because the puncture gets filled with metal. I don't know. So let's get the little wire out of the way. Okay. Let's do a 5 amp here too. Oh, that's already showing a pretty significant drop, but that's probably because it's further down the 12 gauge wire, right? Or not. I don't know. Is it? Please read back and check the link. Okay. But it's a Johnny link, so am I gonna get rickrolled? I don't know. Okay, do you want to leave YouTube? Yeah, I guess so. I shouldn't. I know I shouldn't do this. Go to site. Oh, Coke Vanilla. Nice. 0 sugar. Oh yeah. Who's drinking Coke Vanilla? Johnny, Maker, you want to see this? What? Okay. Anyway, let's see what happens if we only have the middle load enabled, and let's go to 10 amps. Yeah, it's a little bit worse than the first splice, but that can be for multiple reasons. Either this connection is a bit worse, or it's because it's further down the line. So let's turn it off. Let's put this one at 10 amp and see what voltage we get there. So this is 4.83, okay, and this one is 4.58. Okay, so this connection seems a little bit worse than our first one, right? But I guess we can do, I don't know, let's do them all at 10 amps. It's a 12 gauge cable. Yeah, so, of course, this splice does have a lot more cable connected. We didn't do this the scientific way, because if you check here, from the splice going to the meter, there is a pretty significant amount of cable, where, of course, coming from the 12 gauge directly, you know, that has less resistance, and the other one, this one, has a lot less cable connected. So, you know, it's not really too scientific, but it looks like this variant has a slightly higher voltage drop than the other variant. Okay. Yeah, I'd say so. Still, we were targeting 5 amps. So let's go back to 5 amps for all of them. Oh. Oh, you bought them in the Albert Heijn. Oh yeah, nice. Do you like them? I like them sometimes. I normally drink regular Coke, but I like them as a, you know, exotic Coke flavor. Okay, so okay. So how do I describe that? This variant with the. Let me check. No. Let me see which one I should recommend. Right. So we have variant A, B, and C, and I believe A and B. Let me make a little bit of room while the test is running. So I believe variant A and B, which look like that, are basically the same. This one has the stripes go on this top piece, and this one doesn't, as a nut kind of top piece. But other than that, they look pretty much the same. Let's see at the spiky port. Yeah, that looks pretty much the same to me. Okay, but then we have our third variant, which is this guy. Which it does look beefier, actually. I mean, it's bigger. Ah, okay. Yeah, I'd say that's a worse connection, actually. If you look at the spikes, but let me try and stand them up. Does that work? Yeah, you can't really see. If you look at the spikes from this one or this one has a beefier spike, I'd say. Yeah, this one definitely looks better quality, and this is the other variant that basically looks the same. Ah, it's not the same, actually. So the one with the nut top has a kind of tapered edge, so it's really like a spike that becomes wider at the bottom, and this one is just one size all the way through, and this one is actually pretty small, and it seems less quality. So the one with the nut top, and then the sides with you know, the lines running over it, seems to be the best one. Let me check in the links which one is which, because I don't know. Let me open up my own YouTube. Oh god, all links are in Dutch. Why? I always put AliExpress on English and then it reverts back to Dutch for some reason. Really hate it. Yeah, so the first link with the, well, I'll copy it in the chat. This one, those seem to be, no, wait. Ah, I copied the wrong one. Can I delete my comment? Remove. Haha, good. Yeah, it's the last link. Sorry about that. It's this one. So this one looks to be the best one, because that is the one that has the tapered spike. So it starts with a fine point and then goes bigger, and that seems to be working best. Still, if we look at 5 amps, they all seem to be doing pretty good. This is our middle connection, and this is our first connection. But then again, it has less wire connected to it, and it's closer to the power supply. So for 5 amps, I'd say they're all doing perfectly fine, because even the one that's directly on the cable is doing 4.8, and this is doing 4.7 through about the same amount of cable. This one just has an extra connection. So, yeah. Let me zoom that out. Nope. I think that's going to be enough testing. We can check the good one to you know, make sure that one works without twisting wires too. So let's make sure I match these up correctly again. Think. Fleur on the second one. Sure, let me up it to 10 amps. There we go. Everything to 10 amps. We're drawing 30 amps. I mean, 30 amps is nothing to sneeze at. I mean, it's 5 volt, but it's 30 amps. So, yeah. So it's the one that came in this little bag, I think. Yep. Okay, that's not the one that came with the instructions, sadly enough. But, yeah, can't have everything. Okay. So let's get one more of those with the clear or the non-threaded top. So that's this one. Is it? Oh. What? Why am I confused? Well, I guess we can look at the spike, right? Okay, this one has the good spike. This one has a fair spike. This one has a fair spike. This one has a fair spike. This one has a good spike. I don't know anymore. It's just those two are pretty evenly matched. It's just that this one, and I'll take another sample just to make sure if I can find them. No. I'll take another sample and look at the spike. Yeah, I like the spikes of this one better. So the one I linked is correct, and these are just a little bit worse. Not that much. Right, and this has threaded top. Threaded top. It's hard keeping them apart. They're all almost the same. Yeah, okay, anyway. Let's take these. And these are threaded top? No. What? What? Why am I so confused? Yes. Okay. Yes. It's very hard to see if it's a threaded top or not. But, okay. So let's take the one with the threaded top, because I like those best. And do another splice with those, but then non-twisted wires, right? Oh, and they are brittle. They crack. Oh, Maddie B says, I've used these on some low-voltage garden lighting in the northeast USA, and they are brittle. They crack in the cold weather. You are confused because there's no flavor in your Coke, Philip says. Might be, not sure. Still. Okay, so do we want to splice this one again, but then using the better version? Let's do that. Oh wait, we were going to flare stuff, right? Where is the flare? So, it's this connection. And, well, they don't feel hot. Yeah, they're not even warm. So the 14 gauge is 30 degrees, and the connectors are 30 degrees too. I mean, even the 12 gauge is 31 degrees. So the 12 gauge is hotter than the 16 gauge. Where is it? Yeah. No, it's not really heating up. Yeah, the hottest wire is the 12 gauge now. Which is 32, 33, and right at the power supply it's 35 degrees Celsius. So, of course, that's heating up. There's 30 amps going through there, but not by a lot. That's fine. So, let's stop these tests. Turn off the power supply. Yeah, power-wise, I think they're fine. This one is showing a bit more drop than this one. But we're going to replace it now. So that is this connection. And see if that improves it, actually. So let's... I guess we untwist the top one first. Let's see how they come out. Okay. I'll show you that a bit closer. I always get the zoom wrong. It's like USB. It's always the other way. So, okay, this is how they come out of there. Perfectly usable still. Oh. Yeah, for now I'd say so, especially if you get the good variant. We're gonna remove this one and then spike the different variant in the same spot and see if that actually improves it.
What are you afraid of?
Okay.
I'm lost in old ways.
It comes off and on easy enough. It goes on and off easy enough. Yeah, sure, whatever. So let's get the other variant. We can try and spike them almost at the same point, I guess. Shouldn't really matter, but, you know. Okay. If only they were pink. Yeah. You can ask the manufacturer. I'm willing to bet if you're able to commit to 10,000, I'm pretty sure they'll make them in pink. You know. Oh no. Have to try and twist it on there. Okay. Okay. You burnt yourself? Nah, this is a winter rash. My skin doesn't like the cold weather or the low humidity, and then it starts doing that. And I should moisturize, but I don't like that feeling either, so it ends up like that. Okay, so we take our wires. We're not going to change the way we strip them. The only thing we're going to do is insert them through. I'm going to twist them. I know we said we weren't going to twist them. I'm going to twist them. Get it on there, and then untwist it. Okay. Is that acceptable for the non-twisting folk? Yeah, there we go. Right? That's non-twisted enough. So let me twist this one. Get it through there. Yeah, I don't like the moisturizing either, but you know. Okay, so we kind of have them untwisted again. So let's take the positive wire, and we're just gonna kind of jam it up in there, like that. And we screw it down. And let's do the other one first, because otherwise that's going to be all over the place. Of course, now we have two variables again, but it's okay. Yeah, handcam, yeah, something like that. Moisturizing stuff. Steal it from the girlfriend. This camera is always slightly off for me. There we go. Ow! It hurts twisting them this hard, but you know. We want a good connection, so we have to suffer. Ow, ow, ow. Okay, I think that's on there. So, yeah, that's a fine connection at least. Sure, okay. So, let's resume the test, or do the same test again, and see how well it does. Okay, they're all reading 5 volt again. There we go. So, 10 amp. 4.589. So, I think these actually... Well, with them all running, it goes down to 4.39 again. So, it's not that big of a difference if we lower the load on the cable and look at what this connection itself is actually doing through all the cables without loading the cable more. 4.5, sure, that's pretty decent. This one still has a bit better connection, it seems, because it's 4.7. But then again, the amount of cable is a lot more for this one. So first it goes to a lot more 12 gauge, and then it goes to a lot more 14 gauge. So that might actually account for the higher drop versus this one. Right? Teacher Gone Tech, aka Pjoller, says, why does watching this stream always make me end up scrolling through AliExpress to buy more stuff? 2 strips from BTF in the basket again. I know the feeling. I know the feeling. But yeah, even at 10 amps, I'd say, I mean, sure, the voltage drops because we load the cable, but let's say we don't have the end load at 10 amps. 4.5 and 4.6 volts through one of those connections with cables and everything in between. We said that 10% drop over the cables was acceptable, so 0.5 volts. And that's exactly what we're doing. This one's even better. He followed your affiliate link for this load. Oh, yeah. Oh, right. I don't think I linked the loads in there. Maybe you could go back to one of the previous live streams. I think it wasn't there. But I should list it on the equipment page because, well, as you can see, I've been using them a lot. And I really, really like them. They're excellent. They're excellent little loads. Now, let's see if we can make them burn. Because we're at the end of the live stream. And one of these loads can do... Well, it says 30. It can't do 30 amps. But it can do 25 and keep that up. That is 100 watts of power. So we're getting 104 watts of power actively delivered. And the load will get warmer. That's okay. So the other 2 are off. And we're just pulling... Hold on, let me try and unfurl this. Oh wow, this wire is getting hot. Okay, yeah, we're pulling 25 amps through a 16 gauge wire here. So we're now pulling 25 amps through this connection and a 16 gauge cable. And this 16 gauge cable is getting pretty warm, I can tell you. Let's leave that running for a little bit. Yeah, the connector's going to get warm now. Yeah, I think so. So we're at 4.13 volts, but that is definitely also the 16 gauge cable dropping the voltage there. Yeah, I think I'll be adding them to my equipment page. And also the loads, I really like the loads. And they're cheap enough that I can buy 5 instead of buying one big one. They can each do 25 amps, at least at 5 volt. They can't do 25 amps at 12 volt, of course, because then there's more heat to dissipate. But I mostly test at 5 and 12 volts anyway. And having 5 of them, it's just making it so much easier. Because if I had one load, I couldn't do this test. But now, having 5, and still, you know, they're 30 or 35 bucks a piece, I think. They don't make a lot of noise. They dissipate 25 amps just fine because the temperature here is 51 C for the load. You can even hook up an external probe if you want to. You know, for toasty wires. Like this one. I guess I can look it up. Post it in the chat, please. Order history. Always takes a while to load on AliExpress your order history. Or maybe that's just me because my order history is a gazillion pages. My order history on AliExpress is 157 pages. And it's 10 items or 10 listings per page. Not 10 items, it's 10 transactions per page. So if I bought multiple things, that's just one transaction. And I have 157 pages. Send help. Send help. Oh, Johnny's faster. What? Okay. Oh, they're 38 euros now. Okay, maybe wait for a sale, but yeah. Unexpected Maker says, "Holy shiz! You could have retired by now. Yeah, yeah. I when I say I buy a lot on AliExpress, that's no joke. Okay, this is getting toasty. I'm gonna give it another minute. Where can you see your points? There is a place where you can see my AliExpress. Um, where you can see your status for on AliExpress. Member Center? Yeah, yeah, yeah. So in the Member Center, you can see, and so my account Member Center, you can see your reward points. And I'm currently at 8,425. And I believe diamond level is like 3,000, and I'm like way past diamond level. Oh man. Yeah. Yeah, yeah, that's not good. Anyway. That's why I use the affiliate links. You guys have to help me. Yeah, that's a lot of orders. Yeah, when I say I have experience with AliExpress, that's no lie. I mean, so we're currently still at 4.1 volts. The load is at 51 degrees. I think the cable might also be at 51 degrees. Let's take the FLIR again and see. Oh, Draadstaal is also a platinum member. Oh yeah. Yeah, 8,425. And that's for the past year. I mean, did I show you guys my unlock code? Oh no. For the AliExpress fund, also SAKS rules. Absolutely. Yes, it's a random language every time, right? So let's check this cable first. Where is it? There we go. It's twisted together here. Okay, so the cable is at 53 degrees. Let's see this part of the cable. 56. Let me zoom in. I think you can see that. And let me try and focus on the phone. Right, so the cable, the 16 gauge, it's starting to smell a little bit, is 55. Yeah, let's see over here. Oh, okay, this is against the load. That's not good. So let's look at the connection point then, or the connectors, which you can't see. So phone over here, flatter, and then move this in place, right? And then move this out of the way. So the connectors, so the cable is definitely the warmest part, as you can see here, 50 something. And then the connectors themselves don't really show any hot spots. They're 40 degrees, but 40 degrees even for plastic is fine. Let's see the other side. Yeah, they're fine. And I mean, the 12 gauge isn't phased either. So the 12 gauge is, it's warmer than my hand. The 12 gauge is 40 degrees, but there's 25 amps running through there. So, and let's see after the connection. After the reconnection successful. I guess we dropped off of YouTube there for a second. Are we back? Yeah. Okay, so we're back. Good, good, good. I was talking about the cable and how warm it was. And as you can see, it's definitely warmer than my hand. Yeah, 56, 57. It was the 25 amps. Well, it's only at 5 volts. So, you know. But I think these connections are actually holding pretty good. Because we're running 25 amps through there. Yeah, now they look hot. But that's because, you know, there was nothing hotter on the screen. So it's a dynamic scale. So here you can see the connectors. I need to get the wires out of the screen. But if we actually look at them, they're 43, 40, oh, 44. So they're actually doing better than the 16 gauge cable. Or the, sorry, yeah, this is 16 gauge. 57, yeah. And I mean, 25 amps, and we're seeing 4.12 volts. That's pretty good. I don't mind that. That's fine. Yeah. So should we overload the 12 gauge? Let's do it. No. Bam! Okay, more power. Yes, there we go. Now we're pulling 75 amps. And we're down to 3.3, 3.8, 3.3, 3.8. Okay. 75 amps. Let's see what we're pulling from the socket. We are currently pulling 412 watts from the socket. So let's divide that by 5 volt. See how efficient we're doing. 82 amps. Yeah, that's about right. Fire! Yes! No, it's a 12 gauge. It won't catch fire. It's silicone wire too. So let's move these over here slightly, if I can. Let's not touch the hot parts. And let's get the power supply into the screen. There we go. Something like that. Let's see how warm this is. Get out of the way, cables. I messed up the cabling here. Anyway, let's see how warm this is. It's 65 degrees over here. 70 degrees over here. Celsius, not Fahrenheit. 70 degrees Celsius. Over here, it's 85 degrees. It's 95 degrees. Okay, so 75 amps over a 12 gauge cable is a no. It doesn't feel that hot. I can still touch it, but the FLIR says otherwise. Yeah, it says 100 degrees now. Oh yeah, the power supply, yeah. It'll it's hot too. It's a passive power supply too. It's a UHP 500, so it can do 80 amps at 5 volt without dropping voltage whatsoever. So that's good. But yeah, my 12 gauge is now 105 degrees. And it's getting hard to hold. I wouldn't want to hold that for too long. And I mean, this isn't usable. So, I mean, if you look at the meters, you can see that we're at 3.6, 3.1, and 3.7. That's not a usable voltage anymore if you want 5 volt. So, right? I mean, it's just a little fun. Let's go to 15 amps. And now we're back to usable voltages. So, well, it's still 4.2. It's not 5, but it's a lot better. Yeah. But realistically, the end connection would be 5 volt. This one would be 8 amps, or 8 volt, 8 amps. And this one would be 8 amps too. So then if you have a 12 gauge distribution wire, of course it depends on the length, you get 4.7, 4.5, 4.7. That's pretty decent. So there's one test I want to still do, and I'm going to turn these off because if you're burning 25 amps, or 75 amps, guess what? There's also 400 watts of heat being introduced into your room. So it's nice and toasty now. One thing I wanted to test as a last thing is, it says 12 gauge. What machine is that? Which machine are we talking about? Shalim, Washington. But could we get a 10 gauge in here? I need to go the other side. Personal heaters are nice, right? But then I'd rather do it with LEDs. Because then I still get light too. Okay, so let's take this guy and let's see if I can get some 10 gauge cable with my is this 10 gauge? Yeah, so no, this is 10 gauge. Okay. So this is 10 gauge cable, and it's officially not suited for that because it said 12 gauge cable, right? But can we get the little cap on here? Yeah, I think we can. And can we then still screw it down? Let's see. Have to pierce it. Yeah. For the DC USB testers? Yeah, it was in the chat, Shalene Washington. Because then you get an affiliate link, and that's always nicer. There you go. Okay, so 10 gauge also works, right? Because if you're going to distance, especially on a 5-volt system, you basically can't get thick enough wires. So let me do a continuity test on that, just to be sure. But I'd say if it twists on, it's going to be fine. So yeah, these are actually quite nice. I shall be listing them in my equipment page. Let me show you. Let's see what well, we shouldn't get any resistance. Yeah. So, 10 gauge also works. Cool. I don't think you'll be able to get it into the top, so you won't be able to branch off 10 gauge. We already ran into a little bit of trouble with the 14 gauge. But then again, those branch off wires generally wouldn't be that long. So, yeah. Yeah, with the brittle warning, yeah, I can't vouch for that, of course. I mean, I haven't weather tested these. They are intended for the outdoor garden use. So, I don't know about, yeah, I mean... Try not stripping the other end at all. I think the pin will go into the center of the wire. I do not understand what you mean, Dougie. Because... It already went into the center of the wire. I didn't poke through either. Well, of course, this is 10 gauge, so. Oh. Oh. I think I get what you mean. I get what you mean, Doggy. So, you mean to... Well, this won't fit. So, 10 gauge in the top part doesn't work. So, let's try that. Here's some 16 gauge. And what Dougie means is if you put it on like this, so if you put it on like this and don't even strip it, and then you have the top part. Oh, but the top part isn't a pin, Dougie. So the bottom part, which goes into the bus bar cable, that's a pin. But this part is a flat surface, basically. So even if you did this, first it wouldn't grip, right? Because there's nothing gripping the cable now. Yeah, it was a good idea. It's a good idea, but this isn't a pin. And I think it needs the exposed wires to basically twist around in here to also give it the grip it needs, right? So, yeah. Yeah, it was a good idea, but yeah. Why not strip the wire after you insert it into the cap? Oh, yeah, sure. That can work. For sure, yeah. So you just put the cap on there and then strip the wire. Yeah, sure. That can work. Yeah, and for these caps, I'd say 14 gauge is basically the max you can get through there. Okay, I guess we can test 12 gauge. Do we have some 12 gauge? No. Well, I'd say 14 is the max you can get through there. Cool, cool. Let's turn the power supply off before I short circuit something again. Because we're reaching the end of the stream, but I think these tests have been quite successful. If you'd ask me if I could recommend these, I'd say so. Power-wise, they do fine. I mean, we ran 25 amps through them. That's nothing to sneeze at. The wire got 60 degrees, but the connector didn't. Oh, Andelage. Andelage is here. Sorry for being late. Yeah, we've been going for 2 hours already, and we've done the tests, and I was just doing the conclusions. So sorry about that. But yeah, the conclusions is these things. They're not a hazard as far as I can tell, because they don't really heat up that much. Of course, we can't see the metal inside, but if there'd be a lot of resistance there, it would heat up because resistance equals heat, especially if you're running 25 amps through there. And if the cable already got 60 degrees, but the connection point between the two cables is cooler than that, I'd say that connection is pretty decent. I mean, I think that's a good conclusion. And, yeah. So I'll be listing these on my equipment page, and especially if you're doing outdoor projects and you want to use a bus bar, and we tested this with 10 gauge, these are actually a great suggestion by Wing Costa from the Discord server. Because he used them in a project and he linked them and was like, hey, that's interesting. Let's buy those. And then I found various versions on AliExpress, of course. And I'll link the nicest one. Sneak peek time. Yeah, I have been working on stuff, but it's not ready to share yet. We're getting closer to being, ready to share, but it's not there yet. But I guess I can show you the board I showed last time. I did try to get some use out of it. So we have those big posts, which, I got the hole sizes wrong, so I had to hammer them in. And then I managed to solder them, of course. Having the Auxun T3i with a big tip really helped with that, because it just poured in, 100 watts of soldering power, and then I was able to solder that just fine. And for these, I didn't do a top layer bar of solder, but for these I did, and especially when I get the holes right, and I've already ordered new prototype PCBs, when they sink down all the way, because the top also has the exposed pads, basically. It's one big pad, I guess. Yeah, so I'm testing these to design a PCB which is going to need to handle a lot of current. I guess can that be a sneak peek? So I did different configurations. So I tested the fuse holder I often use with 2 of those posts to see how much heat that would put into the PCB. And then I also tested my screw terminals I like to use on. Those are, for instance, on my current QuinLED-Dig-Quad. And then run it through a fuse with the posts. And, well, I guess I can show you how that looks with a fuse on there. Hold on. Can I reach this box over here? Yeah. I'm just going to get a random fuse. I'm going to get a nice and colored one. And then I'm going to tell you not to get those. Because that's part of the reason why I also bought the testers. I wanted to be able to test a lot more load. So I don't want to test 25 amps. I want to test 100 amps, right? And, you know, because otherwise, why would I need those posts and stuff like that? But yeah, these fuses, they, so I got that right. I got the spacing right. They basically go on like this. And you can get these from 20 amps to 250 amps or something like that. Some insane value. But I've been testing different vendors for those, including Little Fuse, which I also use with my pre-assembled parts. And the Little Fuse fuses are excellent, and they fuse at the right values. This fuse, I ran 100 amps through there, and it's a 30 amp rated fuse, and I did so for 10 minutes. It still didn't blow. And then I was like, okay, I don't want to generate more than 100 amps. So, yeah, don't get any of these colored fuses from AliExpress. They're utter shit. I mean, I can't even get them. I can't even get the lowest value to blow with triple its rating. I mean, yeah, I don't know. And then I get a Little Fuse 30 amp fuse, and I put 40 amps on there, and it'll blow in 10 seconds. So, fuses on AliExpress is really hit or miss. Because I have 3 different vendors, which I got 3 different types of these color type fuses from, and they're all shit. So, I guess that speaks again for getting official Little Fuse fuses, which, well, at least I will deliver with my products. But yeah, it's just, you know. But heat-wise, I was able to do some tests with this, because you have to remember, if you look at one of these screw terminals, there's just these 2 little posts here, which will have to transfer all the current. But then if we look at these guys, this one has 6 posts going into the PCB, and 1 post is actually thicker than this whole thing altogether. So once you want to go higher current, I think screw terminals will become less of an option, and we might just have to wire directly to these. And that's actually fine, because if we take the wire we made earlier, let's get it out of the tester. Because you won't be working with 16 or 18 gauge wire at that point anymore either, because you want a lot of current. So we made this 12 gauge wire earlier this stream, and basically what you do, and I'm checking if all the power is off, it is, you'd basically screw it directly onto this post. Now, these are M5 screws, and I believe these are also M5 spaced fork terminals. You can get them in M5, M6 and stuff like that. So you basically just screw this on here directly. No, see, okay, I have to do this while on the table. Because you have to apply a bit of pressure, because otherwise it'll basically push the cable back out again. But then, once it's screwed down, yeah, that's right, this makes a very secure connection, because I can't move it. Wait, is my chat stuck? Or is everyone just mesmerized what's going on? Because, yeah, this is a very... Okay, if I really try, I can move it. Oh, Michael has to leave again, so you're here late, and then you have to leave? Oh. This must be for the 100 channel analog board. Who knows? Who knows? Yeah, so I've basically been testing how to get more current into PCBs. And then I've been testing 2-layer and 4-layer and 2 and 4-layer with VIAs and 1OZ and other configurations and stuff like that, just to find the best way to get power in and out of a PCB and through a fuse, and either using this type of fuse holder or, you know, using the different type or new type of fuses, basically. Yeah, doing lots of tests. We'll be doing more tests in the future, and I might do a live stream about that if it comes in on time. I don't know. And who knows what will come out in the future? Let's leave it at that. I still haven't finished my Coke, so we're still here. Sorry, I'm cheating on you. Another live stream. What live stream is that, Maiko? Is he gone already? Should we send people to another live stream? I'm gonna check on my YouTube. Maybe I can see the live stream too. Oh, there's an EEV block live stream. EEV block 2, actually, but yeah. Okay, let's get a link for that. Share, copy. So, oh, Scott from Adafruit at Twitch Raid. Oh, okay. Yeah, like a Twitch Raid. Let's send them to EEV blog. Okay, so anyone who wants to continue watching a live stream after this one, I think Johnny linked the one from Adafruit, and I linked the one from EEV blog. Yeah, if you want to continue the live stream madness, go over there. Oh, and tell them I sent you. That's always fun. So, I think we learned a lot today. That's good. These things are actually pretty good. I'll be listing them. And thank you for watching. And I hope to see you guys back another time. Another video, comment, Discord server, stuff like that. Okay? Catch you later. Bye-bye.